Alright, in our previous video, we started looking at hypothesis testing, and we started by looking at a motivating example that we had done in the previous module. So we're going to start by looking back at that example with a lot of the math that we'd already done when the first time we did this example. So in our example, we found that we had 140 Chantix users, and 28 of them were still smoke-free after that 9-month period. And so we also calculated the probability of having 28 or less in our sample smoke-free after that 9-month period. So here are some things that we had. So the first thing relating to what we talked about in our previous video is we want this idea of an alternative hypothesis. Right, this or less that we used here relates back to the alternative that we talked about in our previous video. We wanted to show that their success rate was less than that 30% that they had told us. Other things that we had done there, we had calculated a z. And when we calculated this z, we had already found the sampling distribution. So we had the mean of p hat, and we had the standard deviation of p hat, as well as we had p hat itself. So our p hat was that 0.20, which again was just the 28 out of those 140 users. Our mean of our p hat was actually the same as the number that we're using for comparison here as well. So it was our 0.30. And then we had also calculated the standard deviation of p hat, which took into account our p of 0.3 and our sample size of 140. And we got that standard deviation of p hat to 0.38730. And so when we calculated our z-score, we had a z of negative 2.58. In addition, we had drawn a picture to go along with this calculation. So when we had drawn this picture, we had it centered at 0.3 because that was what we were told was that claim. We did some calculation for going out a certain number of standard deviations, but we found that this 0.2 fell about right here, and then we had shaded left. Well, that's exactly what we talked about our picture should look like in the previous video. We're centered at 30%, we have that 20%, we're looking for less than, so we're looking at this one-tailed left-hand side test. Now what I'm going to do is draw this picture a little bit differently, but it's going to be exactly the same. So for this picture, I'm going to draw it based upon the z instead of our p hat. Like right, this was our p hat that we calculated here. Now if you remember from module 1, z is always centered at 0. And if I look at my increments and far away, it's always the same. So I have my -1, my -2, and my -3. And using our p hat, we got a z of -2.58 for our data. And again, we would shade left. So now to understand the connection, the reason why we're actually going to be shading to the left here is because that alternative hypothesis has that less than sign in it. So these two pictures are exactly the same. This is one that we did in the previous set of notes because we felt more comfortable with putting it at 0.3 and putting our p hat on here. But realize if you plugged 0.3 into this equation, you would get 0. And if you plug 0.2 into that equation, you get that -2.58. So it's really the same picture, just written a slightly different way. We also found a probability by utilizing our z table and got our probability of 0.0049. So first realize all the numbers I've put here are the exact same ones that we had previously. Now I'm just going to give these some new names. So our first definition down here is what's called a test statistic. And what a test statistic does is it utilizes your data to help us answer the question of should I reject the null hypothesis or not. Currently, this is going to be our z that we calculated. So our test statistic was this negative 2.58 that we've already calculated. So it's a new name to the same calculation that we were doing. Our other definition here is what's called a p-value. Now, first reading through that, first notice that it is a probability. And we've been calculating probabilities. More specifically, is the probability of observing our data, or more supportive of the alternative, assuming the null is true. Now, that might sound really fancy, but this is exactly what we've been doing. So, assuming the null is true, we'd be centered at 0.3. Our data we got was 0.2. What's or more supportive of HA? Well, that's that less than telling me to shade to the left. So this new name of a p-value, which again maybe feels like it has a more fancy definition, is this same probability that we've already been calculating. So new names, but not new calculations. So these are old calculations. I'm not doing anything different to get those, and we've already been doing. Now that I have this probability, or now thing called a p-value, I can use that to decide between my hypotheses. So what decision did we make about Chantix? Were they over-reporting? So we did actually say that yes, they were over-reporting. What that actually means for us in this formal hypothesis test, it means that we're actually going to reject that null hypothesis, so we no longer believe Chantix, and instead we're going to actually believe our alternative hypothesis, which was that they were over-reporting their success rate. When I do this, when I do actually reject the null hypothesis, this has a fancy name. When I reject the null hypothesis, this is said to be statistically significant. So far the moral should be we're not actually going to be doing new calculations. We're going to take old calculations and formalize them a little bit better to actually make a decision between should I reject the null hypothesis or not. What decision should I make based upon the data I have? What does my data support? So we've talked through one example sort of in pieces here with our old example from the previous module. Next, we're going to talk about how to actually go through some certain steps so that you know what exactly we'd be looking for you to do as you do a hypothesis test.